Okay, in this section we're going to solve quadratic equations by using the quadratic formula. Now make sure you realize the name of this formula here is actually called the quadratic formula, but an equation like this is actually called a quadratic equation. So some students get those mixed up. But this would be a quadratic equation and this is a quadratic formula. Now if you want to know where the quadratic formula comes from, it actually comes from taking a generic quadratic equation like this and then solving for x using the completing the square method that I talked about in the last section. And what you end up getting is you get a solution for x in terms of these three variables a, b, and c. And then that formula is going to be this formula, and you can use that formula to solve any quadratic equation. If you want to see the quadratic equation derived from the completing the square method, then just do a search on YouTube for something like deriving the quadratic formula, and you'll certainly find someone on there that can show you that. I just elected not to show you where it comes from in this lecture. Okay, so now let's take a look at our first quadratic equation here. Here I have a quadratic equation of the form 4x squared minus 8x plus 3. And so the a is the coefficient of the squared term, which is 4. And then the b is the coefficient of the x term, which is negative 8. And then c is the constant term, 3. And then, so what we want to do is to apply this formula. You'll notice it says minus b. So we take the opposite of whatever b is, so that's going to be minus negative 8. And then we do plus or minus the square root of b squared, so that's going to be negative 8 squared, minus 4 times a times c. So that's minus 4 times 4 times 3. Now when we do minus negative 8, that's going to make it a positive 8. And then we have plus or minus the square root, and when we square negative 8, we're going to get 64. And then when we subtract this, we're going to get minus 4 times 3, so that's going to be minus 48. And I almost forgot here, in the denominator is 2a, so you're going to have 2 times a, and since a is 4, that's going to be 2 times 4. So we're going to have 8 in the denominator. Now here, we're going to have, so we take this 8 plus or minus the square root of 64 minus 48 over 8. And we can simplify the radical here, and that's going to be square root of 16, because 64 minus 48 is 16. So I have 8 plus or minus the square root of 16 over 8. And then we know 16 is a perfect square, so that's just simply going to be 8 plus or minus 4 divided by 8. And then we can find out what each of these are going to equal, because this is going to give us two answers. We'll get 8 plus 4, which is 12 over 8. And 12 over 8 reduces to 3 halves. And then we also get 8 minus 4 over 8, which is 4 over 8. And 4 over 8 reduces to 1 half. Okay, now let's take a look at the next one here. On this one, I have a is 3, b is negative 4, and c is negative 6. So a is 3, b is negative 4, and c is negative 6. Now I'm using the variable t here, so my equation's in terms of the variable t, so I really should have written t here. So let me go down here and change these x's to t's, so because I sometimes forget to do that when I switch variables. Okay, now, but you're going to use the same formula, so you're going to have minus b, so that's going to be minus negative 4 since b is negative 4. And then plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is negative 6, all divided by 2 times a, which is 3. So now when you simplify this, minus negative 4 is 4, and when you square the negative 4, you get 16. And then this is going to be 4 times 3 times 6 is 72, but notice you have an even number of negatives here. And when you multiply an even number of negatives, it's going to give you a positive. So you have a negative 4 times 3 times negative 6. That's going to give you a positive 72. So be careful with your sign here. So you're going to get square root of 16 plus 72 in here divided by 6. Now be very careful, because I had to correct this when I had written 98 down here, and I guess I can't add sometimes, so I had to go back and fix it. But 16 plus 72 is 88, and so I end up with 4 plus or minus the square root of 88 all over 6, because remember the 6 came from the 2 times 3. And then when you simplify the square root of 88, you can write the square root of 88 as 4 times 22. And then when you simplify that radical, this radical square root of 88, you can actually write that, take out the square root of 4 here, and you can write that as 2 times the square root of 22. So my final answer here, there's actually two answers. One answer is 4 plus 2 times the square root of 22 divided by 6, and the other one is 4 minus 2 times the square root of 22 divided by 6. Now, one thing that you could do here is, if you'll notice, all three of these terms can be divided by 2. So you could divide all three of these terms by 2 to simplify it. So if you divide 4 by 2, you get 2. If you divide 2 square root of 22 by 2, it'll just cancel the 2, and you just get the square root of 22. And if you divide 6 by 2, you get 3. So I can simplify that answer by reducing those fractions to 2 plus square root of 22 over 3 and 2 minus square root of 22 over 3. Okay, now what you have to do, if it's not written in standard form, you have to get it in standard form before you apply the formula, the quadratic formula. So here this minus 2x and minus 5 are on the wrong side of the equal sign, so I can just move them over to the other side, and then their signs will change to plus. So that'll give me 2x squared plus 2x plus 5 equals 0. Okay, so now I know that a is 2, b is 2, and c is 5. Not negative there, but c is 5. So anyway, c is just positive 5. So now let's do the formula. So we get minus b, so that'd be minus 2, plus or minus the square root of b squared, so plus or minus the square root of 2 squared minus 4 times a, which is 2, times c, which is 5. So here that's going to be 4 minus 40 in the radical. So let's bring that down, and also in the denominator I have 2 times a, so that's going to be 2 times 2, so that's going to be 4 in the denominator. So I'm going to have minus 2 plus or minus the square root of 4 minus 40 all over 4. And we know that 4 minus 40 is negative 36. So I'm going to have minus 2 plus or minus the square root of negative 36 all over 4. Now, the square root of a negative number is not real, but if you've studied the section on complex numbers, then you know the square root of negative 36 is the same as 6i. And if you haven't studied complex numbers, then I would suggest you to skip this problem altogether until you do study complex numbers. But anyway, minus 2 plus or minus 6i over 4 is the answer, so I can write that as minus 2 plus 6i over 4, or minus 2 minus 6i over 4. But again, I can reduce this because I can divide all three of these terms by 2. If I divide minus 2 by 2, I get negative 1. Divide 6i by 2, I get 3i. Divide 4 by 2, I get 2. And similarly, I do the same thing down here. And down here, I get minus 1 minus 3i over 2. So I have minus 1 plus 3i over 2 and minus 1 minus 3i over 2. Okay, now here's another one that's not written in standard form. So basically, you just take this 10 and move it over to the other side, and it becomes minus 10. And now your a is 4, your b is 3, and your c is negative 10. And then you can do minus b, so that'd be minus 3, plus or minus the square root of b squared, so that'd be 3 squared, minus 4 times a, which is 4, times c, which is negative 10. Well, now that's going to be 9, and since you have a negative here and a negative here, we have two negatives, so when you multiply all this together, it's going to be positive 16 times 10, so it's going to be positive 160. And then on the denominator, I have 2 times 4, since a is 4. So I end up with minus 3 plus or minus the square root of 9 plus 160 all over 8. Well, that's going to be minus 3 plus or minus the square root of 169 over 8. And it turns out that 169 is a perfect square, so I can write this as minus 3 plus or minus 13 over 8. So if I do minus 3 plus 13 over 8, I get minus 10 over 8, which reduces to, no, I'm sorry, I get positive 10 over 8, which reduces to 5 over 4. And then if I do minus 13 minus 13 over 8, I get negative 16 over 8, which is negative 2. So my two answers are 5/4 and negative 2. And so that's how you solve problems using the quadratic formula. And again, make sure they're in standard form before you start applying the quadratic formula. I want to finish this up and show you that this portion that's in the radical here, that's the b squared minus 4ac, this portion right here that you see right there, b squared minus 4ac, that's actually got a name. It's called the discriminant. And you might be asked to determine the nature of solutions based on the discriminant. It turns out that if the discriminant is positive, it's going to have two real solutions. So if you go back and look at one of these problems, let's say this first one here, the discriminant turned out to be 16. So that was positive number, and notice that I got two real solutions here. Okay, and then if the discriminant is negative, look at the second case here, and you can see if the discriminant is negative, the quadratic equation has two non-real solutions. And so if you go back up here and look at this problem, you'll see here the discriminant was a negative number, and notice that I got two solutions, but they're non-real solutions. So I got two non-real solutions there as a problem. Now I didn't have one where the discriminant was 0, but if the discriminant was 0, in that case you would only have one real solution. So let me show you how to use the discriminant. I'm just going to do one example. I'll show you how you can look at the discriminant and kind of get the nature of the solution. Okay, so if we took this problem, 2x squared minus 11x plus 5. Okay, well, we know that a is 2, we know that b is negative 11, and we know that c is 5. So when we do this problem, we have b squared, which would be negative 11 squared. We're trying to find the discriminant, so we do b squared. And then we do minus 4ac, so minus 4 times 2 times 5. And so that's negative 11 squared is going to be 121. And here I'm going to be subtracting 40. So 121 minus 40 is actually 81. And since that's a positive number, I know I'm going to have two real solutions. Now again, if that had been a negative number, I would know this quadratic equation has two non-real solutions. And if this had been 0, then I would know the quadratic equation has only one real solution. So you might be able to, you might be asked to identify the number of solutions from a quadratic equation just by looking at the discriminant. And if you do have to do that, then that's how you would go about this method. Now, obviously you could solve the quadratic equation and determine what the nature of the solutions are, but this is so that you don't have to solve it to determine the nature of the solution. Okay, well that pretty much ends the section on using the quadratic formula. In the next section, I'm going to talk about problems that actually lead to quadratic equations. They're not necessarily quadratic equations in the beginning, but we can actually solve quadratic equations to get their solution. So I'll talk about that in the next section.